All right, we should be ready to check the warm-up. Biggest thing here is our answer should only have positive exponents. So in number 1, that is a fraction of 1/2. So this -2 needs to be distributed to each of their exponents. So that's going to become 1 to the -2 over 2 to the -2. Well, we know we're not allowed to have negative exponents, which means they have to switch. So the 2 on the bottom is going to go to the top, and the 1 on top is going to go to the bottom. So that's going to make it 2 now with a positive 2 exponent and 1 with a positive 2 exponent. 2 squared is 4, 1 squared is 1, and then we just want to leave that answer as 4. Number 2, we need to start looking at our bases. The first thing is everything's being multiplied. So with the 8 and the 2, we're going to multiply those two numbers together because they're not exponents and they're not the same base. So 8 times 2 is 16. Then I look at my w's. I have a w cubed and a w to the -6. So when I add 3 plus -6, that's going to make -3. And then the v to the 4th is by itself. There's no other v's, so it just comes along. Well, we have a negative exponent, so we need to change that. So the w -3 needs to go to the bottom. So we end up with 16v to the 4th over w cubed. And there's your two final answers. You should have been checking the classwork yesterday as you went along or at the end of class, which is why there's no answers on here for it. So we're going to start with Module 2 in your workbook. So make sure you've turned to page 29, going back towards the beginning. So we talked about all of our exponent properties, and today we're going to talk about exponents with radicals and then rational exponents. So there's an explore activity. We're going to kind of work through it because it's a little bit confusing to understand from when I went through it. So you've got your radical symbol, which for us is the square root sign. If it has a number inside of it, inside the little check mark, we call that the index. And that tells you how many times you want the same number to multiply to it. So for example, if we want the cubed root of 125, what number times itself 3 times is 125? And that would be 5. 5 times 5 times 5. We reviewed the definition of radicand earlier this year. Radicand is what's inside the radical, in this case the 125, and the whole thing is called a radical expression. Now, your calculators are also useful for this. Most of your calculators, you are going to be looking for this button. Maybe the X and Y are in different positions, but it's that button with an X and a Y and a radical sign. Usually that's going to be above a button, so you're going to have to hit second and the button to get there, or shift for some of your calculators. Now let's practice with the 125 because we know our answer should be 5. Some of you are going to type in the number 3 because that's our index, then second or shift and this button, and then 125. If that gives you 5, that's the way your calculator works. If you don't have 5 yet, hit equals. If that gives you 5, then you're good. Some of you have to type it in opposite or backwards. So if you haven't gotten a 5 yet, then clear your calculator and try typing in 125 and then second and this button, or maybe you don't have to hit second, maybe it's its own button, and then 3 and see if that gives you 5. So at this moment, if you don't have 5 on your scientific calculator yet, find a neighbor who does and ask them to help you. If you don't have a scientific calculator, then you can't do this part, which is why I recommended the scientific this year, not your basic 4 function. So pause this video until everyone knows how to work their calculator that has one with them. All right, so now let's move on to the explore activity. So we have to figure out, how do radicals work with exponents? So if I have the square root of 4, and that's equal to 4k. Well, to get that square root disappeared, to make it gone, we have to do the opposite of square root, which is squaring it. So we're going to take the square root of 4 and square it. And what I do to one side, I have to do to the other. So we're taking 4k and squaring that. Well, the square root sign and the 2 cancel, leaving us with that exponent of 1 here, or just a 4. When I have the k, whoops, sorry, I wrote that k wrong. Let me go back and fix that. And like I said, this and this cancel, leaving us with that 1. Well, we know that the power of a power is what they're calling it. I think we said power to a power, same thing. So we multiply the k and the 2, which is where they got 2k. Well, I know, and this is logical, if the bases are the same, that means, and they're equal to each other, the exponents have to equal each other. So I know that 1 is equal to 2k. Well, let me rewrite it on top here. You should just have it in front of you. To solve for k, we're going to divide both sides by 2. So k equals 1/2, which means the square root of 4 is the same thing as 4 to the 1/2. Now let's try it with the cubed. So go ahead and walk through steps F, G, H, and I, and J, and see if you notice a pattern in what you got for E and what you got for J. And then unpause the video when you're ready to check your steps. All right, so the first thing is we took the cubed root of 8 and cubed it because that's the opposite of the cubed root. And we took 8 to the k and cubed that. So then the 3 here cancel, leaving us with 8 to the 1. And then 8 to the 3k because of 3 times k. Since 8s are the same, we know that 1 has to equal 3k. And to solve for k, we would divide by 3. So k equals 1/3, which means the cubed root of 8 is equal to 8 to the 1/3. So hopefully you noticed a pattern there. If not, we're going to answer that in here in a second. So it says, how can you write the square root or the cubed root of the number n as the number n with an exponent? So if I have the square root of n or the cubed root of n, and I didn't want the radical sign, I wanted to write it as an exponent, how would we do that? Well, the square root of n, we should write it as n to the 1/2, and the cubed root of n to the 1/3. Now, here's where I want you to think a little bit, because we had both of those examples. What if I had the 4th root of n? Take a second. You should have written that as n to the 1/4. So roots are written as fractions with the denominator being the index of the root of the radical. So now, simplifying expressions with rational exponents. This kind of just walks us through what we did there, going back and forth. So when you have the fraction, the number on the bottom of the fraction is your index. And if you have the fraction as the exponent, or the radical, then you turn it into a fraction using that index. So it helps us in order to simplify, because we can't really simplify using a fraction. So we have to change it into a radical. So here they've walked us through a couple. Part A, they have 64 to the 1/3. So they rewrote it as the cubed root of 64. Again, you can use your calculator to find that, or simply think logically about what numbers times itself 3 times would be 64, which is 4. And there's your answer. You can ignore this step here. That's just them showing why it works. In part B, we have kind of an expression. So we have to take the 5th root of 32 and the square root of 81 and then subtract them. So the 5th root of 32 is 2, the square root of 81 is 9, and 2 minus 9 is -7. And again, remember, to find 5th roots, 4th roots, all of that, you do what we did on the first screen with your calculator. And if you need to refresh that, talk it over with a neighbor. We're going to skip question number 2 and work on some practice problems together. So here we go. We're going to do 3 and 5 together, and then you're going to do 4 and 6 on your own. So number 3 says to take the 4th root of 16. So we're going to change that from the fraction to the 4th root of 16. And what number times itself 4 times is 16? Or type this into your calculator, and the answer should be 2. And there it is. So now let's go ahead and do number 5. So number 5, we've got a multi-step problem here. We have 49 to the 1/2, so that becomes 49 square root, because the square root's the one that doesn't have the index, plus the 27 to the 1/3, so that's going to change to the cubed root of 27. Well, the square root of 49, you should definitely not need a calculator for that. That's simply 7, cubed root of 27. Type it into your calculator, or logically, really and truly, the only number that makes sense would be 3. And then 7 plus 3 equals 10. So go ahead and do number 4 and 6. Check with a neighbor once you have your answers. And then if you agree, that's great, hopefully. If you don't agree, discuss it, and then unpause the video when you're all ready to check both 4 and 6. So 125 to the 1/3 means we're taking the cubed root of 125. And that one we actually did on the very first screen. That's simply 5. 6, you have 1,000 to the 1/3, so that's going to change to the cubed root of 1,000. Minus 64 to the 1/6, so that's going to change to the 6th root of 64. Well, the cubed root of 1,000 should have been 10. The 6th root of 64 was 2. And 10 minus 2 equals 8. So hopefully you got both of those ones correct. The chart here you see are the properties of exponents that you worked on the last 3 days. This was their review. I decided to make it a little bit longer. You have your product of powers, which says when you're multiplying, you add the exponents. The quotient of powers, which says when you divide, you're really subtracting the exponents. Power of a product. This one we've talked about, but just as it's the distributive property. It's where you take the exponent and you distribute it to everything inside the parentheses, which really and truly is the same thing as power of the quotient. It's just on the quotient you have to distribute it to the top and to the bottom of the fraction. Power of a power is when you multiply the two exponents together, and then the negative exponent says you can't have a negative exponent, so you have to move its position in the fraction. So again, it's the same rules that we spent the last 3 days. Sometimes you're going to have to identify properties, so you might want to highlight the fact that on page 31, it's a great chart of all those different properties. Now, the second example is what happens when that top number in the fraction isn't a 1. What do we do then? Well, we use a radical house for these. So here's my radical house looking at the 125 to the 2/3. Well, we know 125 goes inside. Well, the number on top, it's getting hot because the sun's beating down on it, so it wants to go inside and cool off. And the 3 on the bottom hasn't gotten any sun, so it wants to stay outside the radical house. Yes, I know, corny saying, but sometimes it helps us remember that. Now, it doesn't matter if you were to square 125 first and then take the cubed root of it, or if you cube it first and then square it. I recommend taking care of the root first because it'll turn your number smaller, which will be easier to work with. So, what's the cubed root of 125? Well, we know that's 5. We then square 5, which tells us 25. So B, we have 81 to the 3/4. So again, I know I'm going to create a radical house. 81 goes inside. The top number wants to get cooled off, so the 3 goes inside the radical house. The 4 at the bottom hasn't had any sun, so it wants to stay outside. The 4th root of 81 is 3. We cube that 3, and we get 27. Same process as what the book is showing you. They're showing you some more detailed steps with the properties. You just need to remember which number goes outside the radical house and which number goes inside. Part C, same thing. So let's look at number 8. Don't worry about question 7. Number 8, instead of 125 to the 2/3, they're asking about 125 to the 3/2. Well, we know that when we have a fractional exponent, we need the radical house. 125 here. What number goes outside is the 2. Now, because it's a 2, we don't really need to write it because square root means a 2, but if it helps you, then you can do that. Now, can you take the square root of 125? And you can check that in your calculator. And the answer is no. So because you can't do that, we can't really simplify it using the same steps. You can write it the same, but this one doesn't simplify. And no, it wouldn't matter if you cube 125 and then take the square root. If you can't square root it first, it's going to be the same way if you try to take care of the exponent first. So now let's look at a few together. We're going to do number 9 and 11 together and leave you 10 and 12. So number 9, we have 8 to the 4/3. So I know I need a radical house. 8 inside. The 4 wants to cool off, so it goes inside. The 3 stays outside. What's the cubed root of 8? Well, that's 2. We raise it to the 4th power. So that means 2 times 2 times 2 times 2. Or in your calculator, 2. And then this button is your exponent key, and then 4. Or for some of you, you're looking for this button. Or x to the y, the letters could be switched. And that should give you 16. Number 11, we have 1 to the 3/5. So we know the 1 goes inside the house for sure. The 3 wants to go inside. The 5 stays outside. What's the 5th root of 1? Well, any root of 1 is simply 1. So we have 1 cubed. Well, 1 cubed means 1 times 1 times 1, which is 1. So go ahead and try number 10 and 12. Check with the neighbors, you're going through them, and then unpause the video to check how you all did. So 25 to the 3/2 should have been set up like this. And again, you don't have to put that 2 there. The square root of 25 is 5. Cube that 5, and we are at 125. The 1,000 to the 4/3 should have been set up like this. The cubed root of 1,000 is 10. 10 to the fourth would be 10,000. 10 times 10 times 10 times 10. So hopefully you got those two answers correct as well. The last thing we need to talk about is when we use them in real world contexts. Well, really that means there's going to be a formula that has an exponent that's a fraction and we have to simplify it by substituting in values and then evaluating it. So the formula they give us here is C equals 72m to the 3/4, and it tells us the approximate number of calories that an animal would need based on their mass or their weight in kilograms. So the Siberian tiger with the mass of 256, we replace the m with 256, and it's to the 3/4. So that means I've got 256 inside the radical house, 3 inside with it, 4 outside with outside. The fourth root of 256 is 4. Cube that 4, which is where they got the 64, and then multiply it times the 72 that was part of the formula to get 4,608. So again, it's the same process, it's just simply using a formula. Part B gives you another example. So again, you can look through this if you need a refresher. So let's look at our last problem of the day. So our formula is C equals 72m to the 3/4, and our mass is 16 kilograms. So go ahead and try this problem. I think you'll do fine on it. Check with the neighbor if you need to, and then unpause the video to check your answer and your work. So we have C equals 72 times 16 to the 3/4. One thing to note here is the 72 is not attached to the 3/4. If it was, there would be parentheses around the 72 and the m. So the 72 is just going to come along for the ride for a little bit. So the 16 goes inside a radical, 3 goes with it, 4 goes on the outside. The fourth root of 16, you should have gotten 2, and then we're going to cube it. So we have 72 times 8. 72 times 8 means 576 calories.